Everyone, welcome to the 9th lecture in this series. In today's lecture, we are going to study in detail about single and double linked list. In specific, we are going to focus on insertion operations at all the three positions, namely first, middle and at the last positions on a single and double linked list. So, these are the contents that we are going to cover with this presentation. First, we will be seeing how to do insertion in a single linked list at all the three positions, and then we will be moving on to double linked list, where we will be discussing how to do insertion at the front, at the end and at any arbitrary position on a double linked list. I hope by this time you all know that linked list being a dynamic data structure, it offers us the flexibility to add as well as delete elements when and where we require. And we have already learnt the concepts of dynamic memory allocation in one of the earlier lectures, where we learnt the use of malloc function to create memory for a node whenever we want to add a new element, and whenever we feel that an element is not at all going to be present in a list, we can free up the space that is occupied by the element. And while we learned the concept of memory allocation, I hope you remember that whenever we allocate memory for a node in a linked list, it is allocated from the heap portion. So, the heap portion is actually meant to allocate memory dynamically for our requirement. So, first let us focus our attention to do insertion at front in a single linked list. As you see this diagram, you could see we have a linked list with 3 elements 20, 30 and 40, and you know, in a linked list these elements, we say that linked list is a linear data structure, but of course for all these 3 elements memory is not allocated at consecutive memory locations. For all the 3 elements, as you see in this list, memory is allocated at diverse locations, but somehow we have created a chain between these nodes in the list with the help of pointers. We have learned this already, and you know, this is a single linked list, and so in a linked list, to mark the beginning of a list, we allocate a specific pointer, or we reserve a specific pointer named head to point to the first node in that list. So, once we reach the first node in the list, then from there we can reach subsequent nodes in the list by following the respective pointers that are part of every node. And you see, the last node in the list, in its address it contains null, which means nothing, and so that marks the end of the single linked list. As you know, now we are going to do insertion at the first position. So, imagine that we want to insert a node with value 10 at the first position. So, the first step which we have to do whenever we do some addition on a linked list is we have to create memory for that new element or new node in that list. And in the last lecture, we have already learnt how to create a new node, how to create a linked list and how to traverse in a linked list. So, the same procedure which we use for creating a node, we will be invoking here as well to allocate memory for the new node. As such, when we allocate memory for a new node, we have set up the node to have 2 fields, one to hold the data and other to hold the pointer. And whenever we create a new node, we actually put up the data in the data part of the node, and we put up the pointer at the next part of the node. And here you could see that we have allocated memory for the node having a value of 10, and we have placed the value of 10 in the data part, and initially as we create a new node, its address part would contain null, and we have set up the pointer named new node to point to the newly allocated or newly created node. Once we have created the new node, the next step is to add this new node to the existing list. And what are the changes we need to make at this point of time is that Since 10 happens to be the first node of the list hereafter, it should point to 20. So, instead of having a value of null at the time of allocation or creation, this node is supposed to have the address of 20. So, the address of 20 is already held in the pointer head. So, first step which we do is that we move the value held in the pointer head to the next portion of the new node. Thereby, we can make 10 to point to 20. And once that step is done, the next thing is that hereafter 10 is going to be the first node in that list, and so we have to make head to point to 10 instead of 20. So, here we can make an assignment of the form head is equal to new node, which will make head to point to the new node named 10. So, these are the two steps which we have to make whenever we try to insert a node at the first position in the list. So, now let us see the associated code for doing insertion in a single linked list, and that too in the first position. So, whatever we have seen in the previous slide, we have shown that programmatically here. So, we have named the procedure as insert node at the beginning, and whatever this module takes as input, the data value that has to be put up in the first node. As I said before, the first step is to allocate memory for the new node, for which we invoke a call to malloc function. We ask for memory to be reserved of size similar to that of the structure definition for node, and we make the pointer new node to point to the first byte of the memory allocated by this malloc function, and then we make a regular check. So, whenever we use malloc function, we use to check whether memory allocation was successful. You know, for us memory is allocated from the heap portion in the data area of main memory. So, we just make a check whether memory allocation was successful at this time, and if null is written, then it means memory allocation is unsuccessful. Otherwise, it seems memory allocation is okay and successful. So, if unsuccessful, we just display a message, and else means memory allocation has been successful. So, the next step which we have to do is we have to place the data into the data part of the new node, and we have to make the next part of the node to contain the value or the address at the pointer head. You know, head had been pointing to the second node, which is 20 now. So, we make the new node's next part to contain the address of 20 in our case, and after that we make the new node to be pointed to by head hereafter, and that is going to be the first node in that list, and after that we just print a message as the data insertion has been successful. So, the second thing is how to do insertion in a single linked list at the end position. So, you know, single linked list is one which has a collection of nodes, and there will be one pointer named head which points to the first node in the list, and ultimately the node whose address part contains null is going to be the last node in that list, and it marks the end of the linked list. Now, we want to have a new node to be inserted at the end of that list. So, in order to achieve this, what we have to do is we have to start traversing the list from the first position. So, the reason for doing this traversal is we may have to find which is the last node in the existing list. So, the condition which we do apply while doing this traversal is that we are going to check the address portion of every node. We want to ensure whether that particular node is the last node in that list. In order to do that, what we do is we check the address part of the node and ensure whether it is null or not. If it is not null, it means some other node is following the list. If it is null, it means that is the last node in our list, and we stop our traversal at that position. It is because we have to add the new node at this position. So, here in this case we have just two nodes in our list. So, we check whether A's address part contains null. it is not so. So, we advance our pointer to the next node, and now we check whether B's address part is null or not. In our case it is null. So, we stop our traversal here. Now, we have to add the new node for in the position following B. So, in general, if we want to add a new node, the general procedure is we have to allocate memory for the new node. So, we get the data from the user, put it up in the data portion of that node, and then we set up the address part of the new node to contain null. And now, we have to attach this new node to the end of this list. So, we have to do only one pointer modification here. So, here this new node is being pointed to by the pointer named new node. So, what I can do straightforwardly is that I have stopped traversal at this point. Let us imagine that the pointer which we have used for traversal is last node. So, now our last node is pointing to the node named B. So, we straight away use this assignment last node next is equivalent to new node, thereby we put up the address of this node in place of the address of node 2. So, thereby we have added this node to this list, new node to this list, and hereafter this list will contain 3 nodes with new node being the last node in this list. So, let us see how to do this via code. So, this is the routine for inserting a node at the last position. So, similar to insertion at front, we are getting just the data to be added in the new node as its argument. First step, we allocate memory for the new node, and that is pointed to by the pointer named new node. We make a regular check whether memory allocation was successful or not. So, if successful, we have to do this. So, first is that we put data in the data part of the node. Next, we have to we assign a value of null to the next part of the new node, and the next step which we have to do is, now we have allocated memory for the new node and we have put up data and address values in the new node. Now, we have to put this node at the proper place in the list. So, to do that we have to initiate traversal now, for which we have used a pointer named temp, and we have to do traversal from the first node in that list. The first node is being pointed to by the pointer named head. So, we assign the value in head to temp. So, we are going to start our traversal here, for which we have used a while loop. So, here what we are going to check is, we are going to check the address portion of every node, and we want to ensure whether it is null or not. If not null, it means some other node is following. So, we have to advance our pointer as temp is equal to temp's next, thereby we move to the next node in that list. If the condition becomes false, then it means we have reached the last node where temp's next will contain value of null. So, once we exit this loop, we will be in the last position in that linked list, and at that position we add the new node. So, we make a pointer modification as temp's next to contain the new node, thereby we have successfully inserted a new node to the end of this list. Now, we focus on how to do insertion at any arbitrary position on a single linked list. As you know, for any insertion, be it first, last or middle, we may have to create a new node. You know the steps for creating a new node. So, in our case, we are focusing on inserting at any position in a list. So, let us consider that we want to insert a node at the nth position. So, if we are going to insert a node at the nth position, we may have to focus our attention to the node preceding and the node following it. So, we will be using the terms n minus 1 and n plus 1. N minus 1 denotes the node preceding the point where it has to be inserted, and n plus 1 denotes the point after which n plus 1 is the node that is immediately following the new node that has been inserted into the list. So, here let us consider this example. We have 4 nodes in this list. each having values 15, 20, 30 and 40. And what you see here is the memory address for every node. You could see here every node's memory address is different. That is what I have been telling. Memory for every node is allocated at some random locations in memory, and we have just created a list or a chain by making every node to contain the address of the successive node. And we have instead of head in this figure, what you see is we have used a pointer named PTR to point to the first node in that list. Now we want to insert a new node with a value of 25 in between 20 and 30. So here what we have to do is we have to first locate where we have to insert. So in our case, you can see that the list appears to be sorted. So we may either specify the position as the third position, or in terms or at times you could say, if you want to preserve the list to be in sorted form, then you can set up the condition as to check whether every element, if 25 is the element which we are going to insert, then I can check with every element's data part, every node's data part, whether it is greater or less. So here 15 is less than 25, so we move to the next. 20 is less than 25, we move to the next. And then we check 30 whether it is 25 is less than 30. If so, we may have to stop here and fix this as the position. So depending upon our requirement, we can write conditions. Now the thing which we have to do here is that so far 20 is followed by the node with value 30, right, and the address of 30 is actually held by the node 20, right, with value 20. Now we want to add 25 here. So we have to do some pointer modifications in order to accommodate this new node into this list. So the first pointer modification which you may assume to do is, you may think that this new node's address has to be placed in the place of 3000, right, in node 2. But if we do that as the first step, then what we will lose is that this 3000 is actually the address of the subsequent node. If I do this as the first step, then I may lose the address of the next node in that list, right. So here what I have to do is I have to do it otherwise. What I should do here is, first and foremost I should take this value and put it in place of new node, right. So that hereafter new node will point to the successive node, which is going to be node 3, and after that I can put up the value of this new node in place of node 2's address part. So we have to be careful about, the ordering of statements, the ordering of pointer assignment matters the most here. The first thing is, we have to preserve the address of the subsequent node and move it to the new node. The second step is that we move new node's address to the existing node, which is preceding node, node 2. So we have to do these two pointer assignments apart from creating a new node with the memory allocation function, right. So let's see the associated code, how to do insertion at any position. So here we get two inputs. One is the data to be added to the list, and other one is the position. And just as insertion at front and last, we first invoke malloc and allocate memory for the node. Then we make a check whether allocation was successful or not, and initially we put up the data in the data part of the node, and we put up null in the address part of the node. And we know we are going to start our traversal, and so we initialize temp to point to head, which is the first node in the list. We always have to be clear here. We always have a pointer named head to point to the first node in the list, and if suppose we want to do a traversal, we just copy the value in head to some other pointer variable. The reason is that if I do anything with head, then head will get displaced from first node to some other node in that list. Then we may lose the first position, the address to the first position in that list. So we never do that. We always keep or retain head to point to the first node in that list. If at all we need to do some operation from the beginning of the list, we just copy the value of head in some other pointer, and so we have copied the value of head into temp. And now we have used a loop to do traversal here. So, here I start from the second node in the list and I move to iterate till position minus 1. So, if 3 is the position where I have to add, then it will be iterate, we will go up to 3 minus 1, which is 2, right. So, here every time what I do is I just advance the pointer one step forward. Temp is equal to temps next will take me to the next node in that list. So, ultimately this loop will stop at a point, I mean one position before where we want to insert. So, at that position only we have to add the new node to that list, and then we make a check whether temp is not equal to null. Surely it will not be null, because temp is actually pointing to some node there, which happens to be the node preceding the place where new node has to be added. Now, as I said before, the first step is that we need to take the address that is available at temp, which is going to be the address of the node immediately following it. So, we take that address first and put it in new node's next part. So, that whatever that was following temp earlier will be the successive node to new node now. Then the next step which we do is that we have to make temp's successor to be new node, right. In order to do that, what we do is we put the address of the new node at temp's next part. So, now we have done the 2 pointer manipulation steps which are essential for doing this insertion here, and finally, we print a message that insertion has been successful. Now, we are going to study how to do insertion in a double linked list. So, similar to a single linked list, in a double linked list also we can do insertion at all the 3 positions. So, we know already what a double linked list is. In a double linked list, every node will have 2 pointers, one to the node following it and one to the node preceding it. So, here every node will have one data part and 2 address parts, and that is how we have made the node definition. And I hope in the last lecture you have witnessed how to do node definitions for a double linked list and how to create a node in a double linked list. So, here we use the terms head to denote to the first node in the list. We use the term previous to denote the pointer pointing to the previous node in the list, and we use the term next to denote the pointer portion or address portion in the node which points to the node immediately following it. So, now we are focusing on insertion at front. So, here what you see is that we have a linked list with one node in this case, in this example, and you could see we have a pointer named head that is pointing to the first node in the list. And you could see that since this node happens to be a only node in that list, you could see its previous as well as next part are shown as into, right, which means they are null at this point of time. Now, we add a new node to the first position in that list. So, in general, for any insertion, first of all we have to allocate memory for the node. We will be making a call to malloc and reserve memory for the new node. And initially we will be placing the data in the data portion of node, which is shown in red here. And to be on the safer side, we always make initial assignments to previous as well as next as null, right. So, now we are going to insert it at the first position. So, there are certain pointer manipulations which we have to do by this time. So, here head has been pointing to the old node so far. Now, the new node has to be the first node of the list, right. So, we may have to revise the head to point to this node. But before that, what we have to do is, since this happens to be the first new node happens to be the first node of that list, it should contain the address of the subsequent node, right. So, so far it has been null. So, we may have to move the address of the earlier node, that is the old node, to the next portion of the new node, right. So, this old node's address is actually held by head at this point of time. So, we actually do this as the first step. First we do pointers previous as null. So, that is what we know. This is going to be null just because this is the first node of the list. So, we leave it as such. The next is we set up pointers next to have the value pointed to by head, thereby the address of this node is moved to the place of here, which is shown in green, right. So, this node will have the address to this node hereafter, and after that, since this is a double linked list, we have to think of the other aspects as well. You know, every node, this node will be following to this node, and this node will be following, pointing to this node as well in a double linked list. So, what we do is head is as such pointing to this node till this time, and so we take heads previous, which means it refers to this portion. Here we set up the address of this new node, which is also pointed to by the pointer named PTR. So, heads previous, we have make an assignment here as to point to PTR. So, this pointer will be active by this time, and head is equal to pointer. So, here what happens is that whatever being pointed to by PTR is going to be pointed to by head now, right. So, thereby you could see that head is now pointing to the node named PTR, and this old thing has been shown in dotted form, which means this link is no more existing, right. Now, this is the new link added, and so hereafter this linked list will have two nodes, with new node being the first node in the list. Next, let us see how to do insertion in a double linked list in the middle position. So, as we saw before, for insertion at any position in a single linked list, we may have to get two arguments here, one the data and other the position. So, similar to what we have seen in single linked list, we may have to locate the n minus 1th position first. For moving to the n minus 1th position, we will be using a pointer named temp. We will be doing our traversal from the beginning of the list. So, here we have set up head as the pointer to the first node, and then we will be doing our traversal from the first node in that list. So, here the criteria which we will be checking here is, we will be looking for positions, right. So, here I want to do insertion at the third position here. So, n minus position would be 2 here. Since I want to add the new node to the third position, n is 3 here. So, my n minus position would be 2. So, I should make a count from first to second in this case. So, once I reach the second position, I may have to stop there, and so my temp would be pointing to the second node in this list. And as temp is pointing to the second node in the list, you could see we have to add this new node. So, first we will be allocating memory for the new node and put the value in the data part of this new node, and initially new nodes previous as well as new nodes next will be having or assigned a value of null, and we have set up one more pointer named PTR to point to the new node as well. So, as you know before, we have to make revisions in pointers at 4 positions. One, we have to look at temps next. Another thing is we have to look at pointers previous as well as next, and then we may have to make a change at the node following PTR's previous position. So, we have to do pointer revisions at 4 positions. In order to do that, you may think that you can do at any order, all these revisions can be done in any order, but it is not so. As I said before, if I make updations to temps next first, then I may be losing the address of the successive node. So, first I should be careful enough to take this address and move to pointers next part. So, that would be my first priority. That is what we have done here. We take the address from temps next, it is actually the address of this node. I move that to pointers next. So, hereafter this pointer will be pointing to the successive node in that list. And the next thing assignment which I do is I look at pointers previous. Hereafter it should point to temp. So, that is what I am doing here. And the next assignment which I make is that I should make temps next to point to PTR instead of this node, right. So, I am just overwriting temps next part with pointers address. So, that is the third statement which we have made, temps next is equal to PTR. And finally, we make the revision here, that is the successor of PTR should contain the address of PTR, right. So, for that we want this node. In order to have this node, we do not have any straightforward pointers. So, what I do is I look at temps next. So, temps next is PTR. So, temps next is actually containing PTR's address, right. So, PTR is actually pointing to this node. So, I am actually looking at temps next previous. So, it actually refers to this portion of the list, and I am placing the address of PTR in place of in the portion shown here, right. So, thereby we have made all the pointer manipulations, and so this new node automatically gets added up to the list. And at last we will be we can see how to do insertion at the end. So, it is very simple, you have to traverse from start. So, as such as we saw with the single linked list, we will be checking the next portion of every node in the list. So, if suppose some node is following this node, then it will have some address, and if suppose it contains null, it means that is going to be the last node of the list. So, here that is the criteria we use for every node to check whether it is the last node of that list. So, once we have reached the last position in that list, we may have to add this new node. As such, we will be creating memory, we will be allocating memory for the new node, and then we have to do pointer add manipulations this way. So, here hereafter a pointer should be next to the node pointed to by temp, right. So, instead of being null, I should put the address of pointer here. So, that is what we have done with the first step, temps next is equivalent to pointer. So, we make pointer to follow temp. Next assignment which I have to make is that I have to make pointers previous to point to temp. That is what we have done as the second step. And finally, as you know, the pointer is going to be the last node of the list, and so its next part should contain the value of null. So, so far what we have seen is that we have seen how to do insertion in a single linked list as well as in a double linked list at all the three positions. And as you see here, we may have to find, first of all, traverse to the desired position in that list, then allocate memory, and then we may have to do some pointer manipulations. So, this is the routine for doing insertion at any position in a double linked list. I hope you will be understanding it better now. So, we make a call to create list, which we saw with the previous lecture first. You know how this display list procedure works. We have seen this in the previous lecture. And as I said before, first of all we allocate in order to create a list, we first create one node and make head to point to it. Then we use a loop to create as many nodes we want, right. We have seen this for a single linked list already, and this is for doing insertion at any position. As I said before, position is going to be one of the arguments. And then as you know, we create we make assignments on we assign the data in the data part, we make pointer manipulations as we said or as we discussed before, and that is what we have done here. To summarize, both in single linked list as well as in double linked list, we could do insertion at all the three positions. And when we do insertion at head, we allocate memory, and then we make head to point to the new node, and whatever be the first node of the list earlier would become the second node of the list, and we will make necessary pointer manipulations. And in case of deletion at or insertion at end in both single and double linked list, we traverse till the last node in the list and attach the new node to the end of the list. And in case of insertion at middle or any position in a list, we look for the n minus 1th position, add the new node to the nth position and make necessary pointer manipulations. So, when we talk of time complexity, if we do insertion at head and as well as at the end, it is going to take us a constant amount of time, and so we say it is order of 1, because irrespective of the number of nodes in that list, always insertion at head and end, that is the first position and at the last position, would take up the similar time, and we say it is constant, and so it is order of 1. And when we talk of insertion at any position, that is middle or any position in that list, it would be order of n. And the key difference of single and double linked list would be that in a double linked list, it offers us the flexibility to traverse in both the directions, but it comes with some cost, that is we have to maintain additional pointers. And these are certain questions which I have put before you for your understanding, to test your understanding of the concepts which we have learned so far. The first question is that what is the time complexity of inserting a node at the head? As I said, it is going to be a constant time, and so it is order of 1. And how do you insert a new node after a given node in a single linked list? It means we are supposed to add a new node at any position, that is at somewhere in the middle in that list. So, we may have to traverse till the n minus 1th position, allocate memory for new node and position the new node immediately after n minus 1 and make up necessary pointer manipulations. And what happens if you try to insert a node at a position larger than the list length? So, here the question is that we say, for instance, I have just 10 nodes in my list, and if suppose I specify the position to be added as 15, in that case there is no such position, and so we may have to fix up a condition to check whether we do not exceed the already number of nodes available in a list, and if we exceed, we may have to exit the function, exit the entire insertion step. The fourth question is, how would you insert a new node in a sorted linked list? So, this was I was mentioning this before. If suppose a linked list is already sorted, then you may have to add a condition instead of looking for position. So, you have to check the value in every node with that of the new node's key, which are the data value, and we have to move till the new node's data is greater than the value held in a particular node. So, if that condition is true, we move to the subsequent positions in the list, and once we have found the desired position, we will be putting or accommodating the new node into the list. The fifth question is, can a double linked list insertion operation be performed if the list is empty, and if so, how? Yes, we can very well do insertion in a double linked list even if it is empty. In that case, this new node will be the first node in that list. So, we may have to make the new nodes previous and the next pointers to be null and make head to point to the node, and this will be the only node in the double linked list. And what are all the additional memory requirements for a double linked list insertion compared to a single linked list? As you know, here for a double linked list, you maintain 2 pointers with every node, which is head and previous, and so that comes with additional cost, because for every pointer you may have to add or reserve additional memory, and that is going to be the additional cost with respect to a double linked list. Hope you will be thorough with the concepts which we have learned so far, and thank you for watching.